Good morning, students, or afternoon if you're in fourth or fifth period. I am going to go over the rest of the student workbook. It is due today. You should be done by now, which is what I said last week. I'm going to go through it to make sure that these answers are correct. I am not going to slow down. I will tell you, though, where these answers can be found. So if you haven't gotten them done or you can't keep up, you should at the very least write down the number of the page where they can be found. You should keep up as best you can. These are going to be due at the end of class today. If you are already done, you should be checking to see if your answers are correct. Once this video is complete, if you're done, great. Go on to the new workbook for this week. There are 2 lessons this week, and we only have 4 days to do it. And like I told you before spring break, we are going hard. We have this week, next week, to get ready for our state testing. So you need to be on top of your game so that we are ready. So we are right now on page 10 of the student workbook from last week. Okay, week 30, I think it was. Yeah, week 30. Okay, so I went over this one with most of the classes. I think I went over it with every class. For this one, it says draw and label an arrow to show how density changes as the mass and the number of particles change in an equal volume. That means, let's say you have a container that's not changing size. If the particles that are in that container have less mass, okay, what's the density like? Or if it compared to when it has more mass, or if it has fewer particles in it. So if you have a container with a few number of particles, or you have a container with a large number of particles, how does the density change? And it wants you to draw and label an arrow. So if you draw and label an arrow, if particles have less mass or there's just fewer of them, they're going to be actually, oh my goodness, my bad. They're going to be less dense. Okay. And then if they have more mass or more particles, they're going to be more dense. Okay. I went over this with most of the classes. So now you should be out on page 30 and with me. Okay. Please keep up. If you didn't have that, that information can be found on page 130. Down here, it says complete the equation with words to show how density is calculated. Give the unit for each part of the equation, then write the equation with the symbols. So here, this information can be found on page 131 of your textbook. Okay, density is measured in grams per centimeter cubed. Okay, and that's because density is equals mass divided by volume. Mass is measured in grams, volume in centimeters cubed. And the equation would be D equals M over V. Okay, you should have that. Down here, it wants you to summarize the 2 properties that change when a material is broken into smaller parts and that one does not. And the one that does not. Okay, I'm sorry. This can be found on page 132. So the mass and the volume of a material can change, but its density doesn't because it's made of the same stuff. So for example, like it shows you in the book on page 132, you could take a piece of chocolate and break it into smaller pieces. A smaller piece is going to have a smaller mass and take up less space, but because it's made of the same stuff, it's going to have the same density. So therefore, the density does not change. That's what this is telling you here. Here it says to analyze the factors that determine the density of an object. Well, this can be found on 132. And if density is equal to the, the density depends on, first of all, the mass of the particles that makes up a substance and the distance between them. If the particles are very far apart, they're going to have less dense, the density is going to be smaller, or if the particles are very close together, it's going to be more dense. So it depends on the mass of the particles and the distance between them. Okay, and then you should make sure to do your summary here. All right, bell's going to ring in a minute, so just be aware of that. Okay, I'm trying to get through this quickly. Here it says summarize the steps used to find the density of a liquid. This can be found on page 134. Okay, if you've got it done, you can check it. If not, then you need to go back to 134 because again, I'm going through it quickly. But you need to. So let's say you have a container that has a liquid in it, and you want to know what the density of the liquid is inside, not the container. Okay, so but you have to measure the mass of the empty container by itself. So let's say you have a glass of liquid. Okay, and then you pour the liquid in, and you measure the total mass of the liquid and the container together. Okay, but you only want the density of the liquid. So what you do then is you subtract the mass of the container that you got in the first step from the total mass. Okay, there's the bell. So you then subtract the mass of the container from the total mass that you saw just to get the mass of the liquid. So for example, let's say I had a container and it's got some liquid in it, okay, and then you want to know what the density of the liquid is. Well, okay, if you measure the mass of the container that's empty, you get that, okay, then you fill it up, and then you with the liquid, and then you take the mass of the liquid plus the beaker together, okay, and then you can subtract whatever you got from the liquor and the beaker and the liquid together, subtract the mass of the beaker, and then you'll just have the mass of the liquid, and then you divide the mass by the volume, and then you get the density. Okay, so that's all on page 134. You can go get that. It says below, the formula below shows how to calculate the volume of a rectangular solid. This is on page 135. You should know that that's the length times the width times the height. Okay. Also, let's say you don't have a block. Let's say it's something like a weird shape like this pen or a rock or any substance, okay? But it's not like a box, and you want to know get the volume. You can use the displacement method. That's what this is talking about. So you can put water in a graduated cylinder and see what the volume is. Okay, then you put the object in the water, and then you see what the water level goes to. So you then will have the combined volume of the water and the object. Okay, then whatever that ending volume is, you subtract the ending volume from the starting volume of the liquid, and then that'll give you the volume of the object. So basically what this is telling you, and again you can find all this on page 136. So let's say you had a graduated cylinder and it had 10 milliliters of water in it. If you put an object in there and the water goes up to 17 milliliters, then you know that 17 minus 10 is 7. So the volume of the object that you put in there must have a volume of 7 milliliters. Okay, next page. Again, I'm gonna go through this quick because people are about to come in. Okay, right here, this is mass, volume, density, regular solid, physical property. Okay, again, you should have this already. If you don't, then okay, you're gonna have to get it done today. I'm just making sure that I go through it for people that have their stuff done. Then you use these same words to answer these down here. This is rectangular solid, density, physical property, volume, and mass. Down here, these are just problems. Okay, right here, this one asks you to find density. Density equals mass over volume. The mass that they give you is 57 grams divided by 144 centimeters cubed. You put that in your calculator, you're gonna get 0.4 grams per centimeter cube. You need to have all this. If you just write the answer down, you are not going to get credit. Down here, they want you to get the volume. Okay, to get the formula for volume, you can use your triangle, cover up the V. The V equals the M over the D. Okay, you write V equals M over D, then you plug in your values. The volume they gave you, or the mass they gave you, was 2.5 grams. The density they gave you was 0.0464 grams per centimeter cube. You put that in your calculator, you get 53.88 centimeters cubed, and that makes sense because we're looking for volume, and centimeters cubed is a unit of volume. Okay, again, you need to have all of that. Okay, this is the last page right here. Number one, a physical property is a property that can be measured without changing the identity of the substance. Number two, okay, if water is poured into an empty glass, the density of the glass, it won't change, okay, because you didn't change what the glass is made of. Okay, so that's why this one stays the same. Okay, it doesn't change what the glass is. Okay, density is the amount of matter per unit volume of material. A regular solid has 6 faces on the block, and they're all rectangular. That's how we get length, mass, or the length times the volume times the height to get the mass of that. Okay, this is just like number one or number two. If a tire is inflated, the density of the tire itself will stay the same. Just because air in it wasn't changed, the overall density, okay, will go down. Okay, but just the tire itself will stay the same. Okay, if the volume of the object increases, so that means you have an object, okay, and then you increase but the mass stays the same, the density will go down, and you can tell that because volume is in the denominator. If this number gets bigger, then the overall density goes down. So you can also think of it this way. Okay, if you have a balloon, okay, and then the mass stays the same, but it gets bigger, the stuff is going to have more space to spread out, so it's going to be less dense. Okay, but you can also look at it from a mathematical standpoint. Okay, this one's mass down here. Okay, same ones as before. You need to do the formulas, write out the stuff, put in your calculations. This one is 6370 grams. This one is 0.15 grams per centimeter cube. This is 9.31. You need to go through. You can look at this for a second. Make sure you have all this. This needs to be done by the end of the day. If you are already done, check your answers. If you are not done, go back and do it. And if you are done again, go on to the stuff for this week because we have to get moving quickly. As you can see, I'm talking here. So make it happen and be ready to work hard this week. We are going fast.